Have you ever really thought about how something complex, like your phone or even a massive airplane, actually gets made? It's not just a bunch of people putting parts together. There's a hidden science behind it all, a field called manufacturing systems theory. And that's what we're going to dig into today, the blueprint for the modern intelligent factory and how it's completely changing the game. So you might be thinking, why change what's worked for 100 years, right? I mean, if it ain't broke, don't fix it. But the thing is, it is kind of broken. The world today is just so different. The old school factory, the one built for cranking out millions of the same thing, just can't keep up anymore. Let me show you what I mean. This slide pretty much says it all. The market of yesterday, super stable, super predictable. You could plan your year out. It was all about mass production. You know, Henry Ford's famous line, any color as long as it's black. But today, forget about it. The market's volatile, and we, the customers, we want everything customized. We want our name on our shoes, we want our car built exactly how we like it, and we want it now. This whole shift to mass customization has basically shattered the old factory model. Okay, so if the old way is broken, how do you even begin to fix something so incredibly complex? You can't just start moving machines around. The first step, and it's the most important one, is you have to understand the system. You've got to find a way to see the invisible, to map out how everything is really flowing on that factory floor. So let's talk about how engineers actually do that. Think about a busy factory. It looks like total chaos, right? You've got machines buzzing, robots moving, parts zipping all over the place. But underneath all that noise, there's a hidden logic. There's a current, a flow. The real genius is in learning how to see the patterns in that chaos, to spot the jams, the bottlenecks, and the waiting lines that you'd never notice just by walking around. And this is where a really powerful tool called queuing theory comes into play. Now I know it sounds super academic, but you already understand it. It's the math behind why you get so annoyed waiting in line for coffee. It's the study of waiting. In a factory, engineers use these exact same ideas to analyze every single waiting line, whether it's a pile of parts waiting for a machine or a chunk of data waiting for an instruction. So, using queuing theory, you can break the whole factory down into these basic building blocks. You've got buffers, just think of those as the waiting rooms for parts. You've got servers, those are the machines or the people actually doing the work. Flow time is just the total time it takes for a product to make its journey. And rework mechanisms, well, those are the detours things have to take when something goes wrong. By measuring each of these, you can zero in on exactly where the delays are coming from. All right, so once you can see the system and you can measure it, well, that's when the fun begins. That's when you can start to actually improve it. And that brings us to the science of efficiency, the tools and tricks for making the whole operation faster, leaner, and a whole lot smarter. One of the most powerful ideas in all of manufacturing is something called the theory of constraints. The concept is actually really simple, but it's profound. It says that in any complex system, there's always one and only one thing that's holding it back. It's the weakest link in the chain. The best analogy, it's like a garden hose with a big kink in it. You can turn the water on full blast, but the flow is never going to be more than what that one little kink allows. So the whole goal is to find that kink, that bottleneck, and focus all your energy there. In this chart shows it perfectly. Look at this production line. Station A is cranking out 100 units an hour. Station C is even faster at 110. But look at poor Station B. It's just chugging along at 45 units per hour. So here's the kicker. It doesn't matter how fast A and C are. The entire factory can only produce 45 units an hour. That's it. Station B is your constraint, your bottleneck. That's the spot you have to fix to make the whole system better. Another huge breakthrough in efficiency is flipping the whole workflow on its head. The old way was called a push system. You'd guess how much you'd sell, make a ton of stuff based on that forecast, and then just push it out there hoping people buy it. As you can imagine, that creates a ton of waste. The modern way is pull control. It's a cornerstone of lean manufacturing. You don't make a single thing until a real customer actually orders it. It's like the difference between an all-you-can-eat buffet where they make food in advance and a lot gets thrown out versus a restaurant where the chef only starts cooking your meal after you've ordered. But here's the thing. Just making today's factory more efficient isn't enough. Not anymore. The market's always changing, right? What works today might be totally obsolete next year. So the real holy grail, the ultimate goal, is to build a factory that's designed from day one to adapt to a future you can't even predict yet. I mean, really just pause and think about that for a second. What if, when a brand new product comes along or demand just goes crazy, your factory could literally reconfigure itself, change its own layout, its machines, its software, almost in real time. It sounds like something out of a sci-fi movie, but believe it or not, this is where we're headed. This incredible idea is called a reconfigurable manufacturing system, or RMS. This is the ultimate weapon against that volatile market we were just talking about. An RMS is a system designed for change. Its components are modular, so you can add them, remove them, or rearrange them on the fly to meet whatever the market throws at you. It's basically like a factory built out of Legos. And just look at what a system like this can do. Every single one of these capabilities is a direct answer to the challenges we talked about at the beginning. It tames market volatility, it thrives on crazy product variety, and it loves those small, custom batch orders that would bring a traditional factory to its knees. This is a system built not just to be efficient, but to be resilient. And even something as complex as adding robots isn't just guesswork. It's not like you just buy one and plug it in. It's this incredibly rigorous and methodical process. You start by analyzing the whole system's needs, you plan the layout, you run tons of simulations to see how it'll perform, and you make sure it actually makes financial sense. Every single step is engineered to make sure that new robot makes the entire system better, not just one little part of it.
So we've gone through a lot of theory, a lot of concepts. But what does it all mean in the real world? Why does this whole blueprint for an intelligent factory actually matter? Well, let's take a look at some of the real-world impacts.
The impact is honestly everywhere. These exact principles are being used right now to build custom wings for massive passenger jets. They're being used to completely redesign car factories for new electric vehicles. They're helping companies become insanely flexible and responsive. It's even being used for things like optimizing energy use and making critical products way more reliable. So this isn't just theory, it's a real-world competitive advantage. And this quote it sums up the whole shift perfectly. We have to stop thinking about a factory as just a big building full of machines. The factory of the future is so much more. It's a living system, one that thinks, one that adapts, and one that's always evolving. All right, so let's boil this all down. What are the big things to remember? First, the market today is wild, and it's not going back. Second, we have these amazing tools from systems theory to help us understand and manage that complexity. But maybe the most important takeaway is that the goal has changed. It's not just about being fast anymore, it's about being adaptable. And these reconfigurable systems, that's the blueprint for how we're going to get there. And that leaves us with one last kind of mind-blowing thought to chew on. We are building factories that are starting to act like living organisms. They can learn, they can adapt, they can evolve. So if they can solve the massive problem of mass customization, what other giant human problems could a system like that help us solve next? Really makes you wonder.